All right, welcome back. Today, we're going to do something pretty cool. We're taking algebra, all those X's and Y's, and we're turning it into a picture. We're going to see how even a simple equation can tell a really powerful visual story.
I mean, think about it for a second. We usually see equations as, well, just a math problem we have to solve, right? A bunch of numbers and letters. But what if we started looking at them like they're a script, like a set of instructions for telling a story on a graph?
And that's really the secret here. At its heart, algebra is just a language. It's a way to describe how different things are related to each other. So today, we're basically becoming translators. We're going to turn that language into something we can actually see and understand way more easily.
Okay, so let's start with the most basic story you can tell in algebra, a simple straight line.
A linear equation, that's what we call it, describes a relationship that is super consistent, totally predictable. It means for every step you take in one direction, you take a predictable step in another. It's this straight, unchanging path, and our job is just to figure out how to draw it.
So how do we draw this path? Well, it turns out we only need two key landmarks to get our bearings. We call these the intercepts. Just think of them as the points where our line's story starts or ends on the edges of our map. Where it hits that horizontal x-axis and that vertical y-axis.
And finding them is surprisingly easy. Seriously, to find where it crosses the x-axis, you just pretend y is 0 and figure out what x has to be. Then, to find the y-intercept, you do the opposite. Pretend x is 0 and solve for y. Once you've got those 2 points, you just pop them on the graph, connect them with a ruler, and bam! You've just graphed an entire equation.
But, stories aren't always that simple. What happens when the relationship isn't about things being perfectly equal? Well, this is where our story gets a major plot twist.
Check this out. The only difference here is one tiny symbol. That equal sign on the left, it gives us one single, specific line of answers. But the moment we switch it to a greater than sign, like on the right, it blows the whole thing wide open. It's not about a single path anymore. It's about a whole territory of possible answers.
And this is the big idea. So let this sink in. We're shifting from finding a line to finding an entire area. We're not just drawing a border anymore. We're literally mapping out an entire country of solutions.
So, the big question is, how in the world do we map out this whole territory? Let's get right into it.
It actually starts out the same way. First, you just pretend it's a regular equation, and you draw the line. We call this the boundary line. But then, we have to make a couple of really key decisions. First, is that boundary line itself part of the answer? And second, which side of the line has all the good stuff, all our correct solutions?
So for that first decision, here's the rule, and it's super simple. If your inequality has that or equal to part, that little extra line underneath the symbol, you draw a solid line. That means the line itself is included. If it's strictly greater than or less than, with no little line, you draw a dashed or dotted line.
Think of that dashed line like a fence. It marks the edge of the property, but you can't actually stand on the fence. It's the border of your solution area, but it's not actually in the solution area. It's a super important visual cue.
Okay, so now for the fun part. How do we know which side of the line to shade? We kind of cheat. We pick the easiest test point imaginable. The middle of the graph, 0, 0, is almost always the best pick. You plug x equals 0 and y equals 0 into your inequality. If it makes the statement true, you shade that entire side, the side with your test point. If it comes out false, you know all the answers must be on the other side, so you shade there instead. It's as simple as that.
So let's just step back for a second and appreciate what you've just learned how to do. This isn't just some random math exercise. This is like unlocking a new superpower. You can now take a statement that looks like a total jumble of symbols and turn it into a clear picture that tells a whole story. A story about a border and an entire region of infinite possibilities. That is a huge shift in perspective. So, let's just quickly recap what's in your toolkit now. You can graph any straight line just by finding 2 points. You get the huge difference between an equation and an inequality. You can graph that inequality, boundary line, shaded area, the whole shebang. And most importantly, you can take a complex problem and make it simple, make it visual. That is an incredibly powerful tool. So I'm going to leave you with this question. This skill goes way beyond a math class, right? You can use it to figure out things like budget constraints or to understand scientific data. So now that you know how to draw and read these visual stories, what relationships out there in the world are you going to try to understand next?